Joining us today is a man known by many as the Transformer King, Drew Welton. Many of you may be familiar with AEMC's Greg Wong from our recent interview. I asked Greg who would be the best suited to discuss transformers, and without any hesitation, his answer was Drew. Drew has held sales management roles in the power industry dating all the way back to 1989, starting with Beckwith Electric, Arriva T&D, Omicron, and now serves as a VP of sales for Intellerent, which provides electrical testing equipment to the power industry. So how does a VP of sales know so much about transformers? Drew is also a 25-year senior member of the IEEE Power and Energy Society and the IEEE Industry Applications Society, and an active member of the Transformers Committee, and has contributed to a number of IEEE Power System Relaying Committee working groups and presents at various industry conferences, including a wonderful presentation at Power Test 2024 on the life extension of power transformers through proper moisture management. Say that a couple times. It'll definitely throw you off a little bit. But that is the primary topic of today's discussion. And it was a last minute decision, but Drew is actually at the IEEE T&D conference out in Anaheim, California, which I thought was a very unique twist on our interview. Drew, thanks so much for taking the time to join us today. Can you tell our audience a little bit more about yourself?
Oh, well, thank you, Micah. And yeah, it is really fascinating to be here and doing this interview from such a big event. It's my understanding that we have some 13,000 attendees, and that's
That's impressive.
registered guests and vendors, and everybody in the power industry seems to want to be at this show, and it's a great event. And the funny thing about it is, when I got started in this industry with Beckwith Electric as an area sales manager, promoted out of tech support, and this location was my very first trade show for T&D. That was 30 years ago, and
That is
hasn't
awesome.
been back to Anaheim since then. So it's a bit of a milestone for me at this point. But thank you for having me today, Mike. I always look forward to sharing information that, and I want to disclose this with no uncertainty. I did not invent this information. And rarely do many presenters actually invent what they present. But the great thing about being in IEEE and getting to sit with industry experts is, you never want to stop that thirst for knowledge and learning something new. So,
Absolutely.
I'm very passionate about this topic. I've served on a number of working groups that have been directed at moisture management, including assessment and mitigation processes and things as such. And it's just really, I'm very happy to always share information with regards to specific topics I'm passionate about.
I love it. And there's just something about the giving back, and I see it throughout the power industry, and it's truly awesome. And this is something that comes up time and time again when we're having the conversations, is the more seasoned folks that are in the industry have all of this collective wisdom and knowledge. And this is just another methodology for sharing it. You understand the importance of that. You're out there consistently putting out the information, and hopefully, getting the youth or the younger technicians and engineers in the realm up to speed, because once that information's gone, it's just gone. So truly awesome. And thank you for taking the time to share.
My pleasure.
As you know, we put out this information just to help collectively better folks with their knowledge and give them resources as well. So truly appreciate you taking the time, and such a cool place to do it from. And for the audience, this was Drew's like, I'm going to be at the IEEE T&D show. You want to do it from there? And I'm like, absolutely. Let's rock and roll it.
Well, it's just after 9 o'clock. The show opens in about an hour, and this is like the calm before the storm. They just brought the lights up, and people are walking by, getting their booths ready to set up, and just at 10 o'clock the doors open and the madness begins.
I know it does. Well, I know you're on semi-limited timeline before the audio will probably get a little bit untenable there. So I'll kind of roll in here, and knowing a little more about transformers than the fact that there are maybe CTs, PSUs, GSU step up, step downs. I decided it would be best to let Drew share the highlights of his presentation and I'll just ask the dumb layman questions as we go along, which is kind of what I consider to be my primary role in these, is somebody just that is just genuinely curious
Hmm.
about the topics within the power industry. So with
Sure.
that being said, for the audience, of course, this is a transformer talk, and we'll kind of
Hmm.
dive right into the questions here. And so with regards to your presentation, I found it to be fantastic. I've reviewed the PowerPoints a couple of times. Where does the moisture actually come from with regards to the overarching presentation? Where does that even start?
Well, that's a great place to start with when we talk about water and transformers, Micah, and it's very important to understand where moisture comes from. And the very first thing we have to be aware of, it can come within the transformer from the factory.
Really?
Now, what they do at the factory is they'll take the transformer, the core, with all the windings, put it into an oven. It's called vapor phase chamber, and actually heat the windings of the transformer up, and then vacuum away all the moisture. But and that is typically very effective. They've been doing this method for years and years to make sure you start with dry insulation. The problem is, from that point, they take it out of that chamber, they put the tank on it, they transport it, they fill it with oil, they put the bushings on, the radiators on, and get it all ready to go. There's a certain amount of opportunity for water to get ingressed into the transformer, even before it goes live, and in service. So that's one area. I mean, IEEE has recommendations that it should be less than 0.5% moisture in the transformer. And if you think about it, if you go from if you're on a very, very large transformer, let's say 25 tons, and you've got all this cellulose, if you're at 2% moisture, or 2% water in the insulation, that's 99 gallons before that you have to take out before
Right.
that can actually be in service. So I
Wow.
think one of the things we miss when we're commissioning a brand new transformer is doing a thorough moisture assessment. We'll get into that just a little bit. Other means of moisture getting in is leaky gaskets around the bushings or the radiators. And there's one thing to keep in mind, and being a boater, I know this because when something like oil or something fluids are coming out of a seal that's supposed to be sealed, water's getting in.
Right.
So I hear this a lot in the field. Well, yeah, that bushing's been leaking. We replaced it, or this, radiator seal is gone, or, whatever the case may be. And it's been leaking some mineral oil. We topped it off. We fixed the seal. Well, did you check for water?
Right.
Did you perform that type of test? So now the other thing, and I think the industry kind of misses this topic, because I remember years ago I was out in Colorado and I was doing a presentation on moisture management. Now, this is maybe 20 years ago. And one of the engineers said to me, "Well, we don't get really concerned about moisture because we're so dry up here. We're a mile in the air. We have zero humidity." And I said, "Well, although my every time I venture up to those altitudes, my lips get chapped and my sinuses start to dry up." I said,
Right.
I can appreciate it having an effect on that, but really what people aren't aware of is that moisture in the insulation itself comes from the natural aging. What happens is the 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 insulation, the paper insulation, is made up of polymers and resins. And when these resins start to get old and start to get brittle and they start to break down, the resin bonds break apart, and the byproduct of that is water. So even if you've never had any ingress from the outside atmosphere, water can be generated just from the natural aging of the insulation itself. And
Gotcha.
I think a lot of people don't pay quite a bit of attention to that. So that's our biggest concern, especially with aging transformers.
Now, with regards to that, so just and this is to keep it at the layman rudimentary
Sure.
terms. So, is the primary introduction of moisture or water that's typically environmental, or is it usually, or is there like would you typically see in a rainstorm perhaps that some of that enters, or is it
Well,
varying degrees of severity?
if you were, let's say, to replace a bushing, and you're taking the bushing off the tank, and at that point you're exposing, the oil in the transformer. You're exposing that to whatever's in the atmosphere. Now, if it's a relatively dry day and you perform the task fairly quickly, you're not really going to have a problem. If you do it in the middle of a rainstorm, you got a big problem.
Right.
And believe it or not, this happens. There was a utility that I just recently worked with that water got in because they didn't seat the bushing properly, and it just sat
Gotcha.
there unseated, and water was just flowing into the transformer. And so it depends on the environment. But the big concern is the natural aging of the insulation. That's really what the gist of the issues are. I mean, most people fix leaks pretty fast, and you have to have a bad humid or rainy day to get a significant amount of water inside. But nonetheless, it can certainly happen.
Gotcha. And this is one of those things too. With whenever I had my conversation with Tom Sendry, we
Hmm.
discussed partial discharge and
Hmm.
treeing due to some cavitation or space in the dielectric, and it sounds as if this can occur in a transformer due to excessive moisture as well. Or kind of like, what are the ramifications? I
Well,
guess so. Why is moisture important, or
yeah.
moisture abatement?
Well, what you have to understand is there are three components to aging of a transformer and how rapidly it ages. Number one is oxygen. Okay, more oxygen, more issues. The other is heat, and heat can come from a number of things. It can come from being the transformer being overloaded on a continuous basis. It can come from poor cooling systems, and those are the two out of the three. And the third one is, of course, moisture. So the higher the percentage of moisture and the hotter you run your transformer, the quicker the insulation is going to start to break down. And what happens when you have moisture in the insulation is you lower what's called the bubbling point, and that means is that
Gotcha.
this water is trying to escape, and as it's trying to escape, it creates little voids in the insulation. Those are the voids that lead to partial discharge and can eventually lead to, a breakdown in the insulation. Now, one of the questions I get is, well, Drew, you know, historically, how many transformers has failed because of excessive moisture? And I'm like, I don't know. I mean, you might know because you had a historical analysis of how much water was in there
Right.
before it failed, but it's considered, can be easily considered to be an insulation failure. Well, the insulation failed. Well, what caused the insulation to fail?
Right.
So, and this is one of the things, and it's a shame because you can dramatically slow down the aging and the life expectancy of that transformer by taking care of the water that's gotten in there. And because a lot of people say to me, well, if the insulation's breaking down and that's creating water and we take the water out, the insulation's still breaking down. It's like, no, here's your life expectancy. You take out the water and it goes just a little bit like that. So, and one of the reasons we focus on this, Mike, is because it is so difficult to get a replacement transformer these days. I mean, our lead times have gotten out to years, not
I've
months.
heard in some cases with GSUs, it can be up to like 5 years.
Oh,
And
four
it
and
sounds
five
like
years
they're,
easily.
yeah.
Yeah. Yep.
And it,
So,
it does sound like it's kind of eased a little bit. Have you seen a
mhm,
little bit of the easing of the supply chain issues recently, or is it still sitting
no.
pretty heavy on the 5 year? Okay.
Well, what's gotten better is the planning ahead.
Okay. Gotcha. Gotcha.
Yep.
Gotcha. Oh, mercy. And so now that we kind of know, I mean, it makes sense to me from a logical perspective why the moisture's bad. You break down the insulation
Yeah.
and things of that nature. What are some of the things that we can do to test for that? And I know a vast majority of the field technicians and engineers rely heavily on measuring like the parts per million of water molecules
Right.
or
Yep.
something like that. But I heard you mention prior at while we were at Power Test that there's
Mhm.
even issues with that. Can you kind of walk us through that?
Oh, absolutely. First of all, the laboratory analysis is an absolutely necessary thing. We've got to look at gassing. We've got to look at the chemical compounds that are present in the oil, and help us determine. And whenever you're testing a transformer and you're looking at a possible bad situation, it's never just one test that you do that you rely on. We always do the standard, the power factor, the excitation. We do the TTR, and we do our winding resistance, and it's not always how you do what you do in terms of the test. It's how you do it and how you perform the test. And one of the big things is problems with pulling a DGA specific to finding out the water content, and it is
Now
in a
that's the
parts per
dissolved gas
million.
analysis. Is that what
Yes,
that is? Okay.
correct. And this is the most common way that people have always done a moisture assessment. And I'll tell you a few problems with that. First of all, when you take a transformer offline, and typically you're going to take it offline to start your test, and that's the first test you perform, the transformer starts to cool down. As the transformer cools down, the water content between the oil and the insulation, it starts to move into the insulation from the oil. So it's
Gotcha.
not always at what we call an equilibrium. It is when you're at operating temperature, but the colder the windings start to get and the oil starts to cool down, that water goes right back into the insulation, and it hides in little pockets and voids and things. And, it's like little molecules hiding over here. So when you do a dissolved gas analysis, it's very, very important to get an accurate a measurement of the temperature, because when the laboratory sees the oil temperature and the ppm, they apply what's called an equilibrium curve. And they consider that, well, at that temperature, there was this much percentage of water in the insulation versus this much in the oil. So they kind of try and balance it out, and it's not very accurate. Um,
Gotcha.
I was
Now,
over.
quick question on that, Drew. So I'm
Sure.
just trying to work through like my slow brain over here through it, but it sounds like it kind of ties into the thermodynamic principles of kind of like the movement. So as the
Yeah.
temperatures draw down, the water is going to
Yep.
be drawn towards the cooler aspect of it, and then that's going
Yes.
to mess up your readings. Is that
Yeah,
pretty
very
accurate?
good. That's very
Okay.
accurate. Good call.
Yes.
But yeah, so we did an experiment once. We were at a substation over in Austria when I was with Omicron, and we went and we pulled 5 oil samples, the same methods, at the same time, same transformer, sent them off to 5 different labs, and got very drastically different results.
That's
Um,
interesting.
and that can be due to a number of things. It could be due to handling. Okay, is the first sample have more water than the second sample or the third? What happens when you put vinegar and oil together? What's on the bottom?
Right.
The water,
The
right?
yeah the
Where are
yeah
you
yep
drawing your sample from? The bottom of the
the
tank.
bottom.
Okay, that's why you have to
Gotcha.
draw off a gallon or so of mineral oil before you actually take your sample, but you're still not equal in terms of moisture content from top to bottom. Or
And it doesn't
from
sound like the water molecules don't equally disperse through a sample either. So it's not a
correct.
uniform,
Yep.
which could probably indicate some of the
Yep.
issues there as well. Is
And
that kind
yeah,
of
and then if it's not handled properly, between the sample and getting to the lab, any exposure to the atmosphere can over give you an estimation. So um, there's a couple of techniques that I've come to know that I really like and appreciate, because you can save yourself a lot of time and aggravation. The
definitely a good
very
thing?
first is, aside from your oil sample, the next thing is doing your power factor um, measurement. And what some of the manufacturers provide us with now is a voltage source that has a variable frequency or variable voltage, um, signal. And so if we traditionally take a power factor test at the nominal frequency of 60 hertz, and we see our CHL measurement start to just increase just a little bit. So the initial thought is, well, that's just, natural aging. It's still within tolerance. I mean, the power factor is giving you an overall impression of the total insulating system. So if we actually take that frequency signal and drop it down, say from 1 or 10 hertz up to 60, we see a better indication of what we call conductive losses. Now, if your power factor is elevated in that range, you have what we call conductive losses. Now, that could be furans, it could be inert gas, it could be sludge, but it's also the first indication that I have a moisture issue.
Gotcha.
Um,
And speaking of, so what are some of the other things that would kind of be introduced? So you mentioned sludge. Is that just
mhm.
a byproduct of the decay of the insulating
Oh
material and
yeah,
kind of
yep.
landing, or
It's like
because to
like
me,
what?
like ideally, I see it kind of like this monstrous sanitized unit, and so you shouldn't get like your typical dirts and dust and debris and stuff. But
No,
so to me, the only thing that's really
no.
filling
It's
is
remember
the
it's
insulation.
flowing through a radiator, getting heated up and
There
cooling
you
down, and just well, it's like your car engine, right? I mean,
makes sense.
that just happens. But
Gotcha.
what I would say then is, okay, so I've got conductive losses. Now I have to figure out, is that really is that just byproduct, or is that water?
Right.
So then I look at my DGA and I look at the ppm and I compare the two. And if that's showing elevated and that power factor is showing elevated, then I always suggest going on to a next step, and I'll get to that in just a minute. But conversely, Micah, if you're seeing a lower power factor in that range, that means you have no conductive losses. Okay, now compare
Gotcha.
that to your ppm. If your ppm is showing normal moisture content, you don't have an issue. Stop, go on to the next test. Okay, we're good to go. However, let's say you're getting that lower slope and your ppm still shows very elevated. Take another sample
Gotcha.
or go to
Now,
the
is there an
next step.
ideal number of samples to take? Like, if you're starting to see some indeterminate readings across your testing and stuff outside of sending it off to a lab, what
Yeah.
are some of the things technicians can do at the
Okay.
time to kind of
Okay.
remedy that or get
Well,
a
good
more
good question,
distributed?
because the definitive answer is this: if I have conflicting results, or I'm showing results that suspect for water, now it's time to do the dielectric frequency response, or DFR
Got
test
DFR.
that we're going to
Gotcha.
get to.
All right. Awesome.
Now, let me just kind of preface this by giving you a little history lesson. The University of Stuttgart, I believe it was doing some further testing to see, because we knew these lower frequency ranges would highlight these conductive losses. Well, what if we took that way, way down to the megahertz range, and then measured it in that and see what characteristics we were seeing based on moisture content? Well, it turns out that they could actually model the geometry of the response of the power factor, or tangent delta as they refer to it,
Right. Tan
and
Delta. Yep.
equate that to laboratory verified samples
Hmm.
that had certain percentage of water in them.
So
So
basically,
by
they had done the research to get a control group to where they knew
Yep,
the exact amount, and then I'm
yep,
assuming they probably vetted the heck out of the
oh
base
yeah,
sample so that your what do you call it, your sample in
hmm,
sample size is accurate for measurement,
sure,
basically.
yep,
Gotcha.
and it proved to be very, very effective. They developed the modeling, turned it into a product from a number of different manufacturers, and it's been on the market and part of an IEEE recommended practice now for since 1997. I think is when
Wow.
IEEE first started to, develop this standard with the confidence that they'd had enough information to. So it's a not only is an IEEE recommended standard for moisture assessment, it's also part of CGRE, which is of course the European counterpart.
Understood. And then,
Yep.
so are you seeing the implementation of that particular type of testing more? And then, what are some of the encumbrances that maybe come into play that would prevent people
Well,
from adopting it?
I'll tell you what prevents it, and I might be a little bit.
I think I know the answer, but
Yeah, I'm a little bit. Not every manufacturer that has transformer test equipment has a DFR device,
that's kind of what I was
and those that don't have one haven't necessarily supported the process, of course. But I think one of the things is people just don't understand this. Now, I gave this presentation at NETA, um, at Power Test, and I got my comments back from the audience, and we scored very high. They loved the presentation generally. What they didn't like is the fact that the room was a little bit too crowded and people were in standing room only. But I guess I draw a nice crowd. I don't know, but
Absolutely.
but one of the comments I got was, or the 90% of the people on their comment session wrote, learned about DFR,
That
finally learned
that's
about
crazy.
DFR.
Interesting.
And I was at the last T&D show I was at 15, 16 months ago. I actually had a NINA technician come by the booth, and his specialty was been transformers for 20 some odd years. He knew everything about transformers. And I said, well, I said, do you do DFR in terms of moisture assessment? Because I had one of the devices right behind me, and he goes, nope, I'd never do it. And I said, what do you mean? And he said, well, I don't believe in it. And I said, well, it's not politics or religion or a vaccine. I
Right.
said, it's science. It's a recommended standard. He said, well,
Right.
I'd do it if my customer told me to do it. So here's the dilemma that we have, Micah. When you're a testing contractor, and let's say you're part of the sales team, and you have a customer that has a bid come out that says, go test these 4 transformers. And he says, here's what I want you to do. How much is it going to cost? And they look at it and say, oh, yeah, power factor, this, that, oil sample. Yeah, we can do that. Here's what it'll cost. Without ever mentioning the fact that, well, is it important possibly with, based on the age of these transformers that we check for water? I mean,
Right.
isn't it? Don't you think that is kind of important? Well, no, we cover that with our DGA. I just wonder how many people have gone through the whole process of pulling in a processing truck, processing the oil, doing a hot oil spray, pulling a vacuum, doing all what they do without really having a clear understanding of how much water was in that transformer.
Well, and would they have an indication? So, like you said, it goes to the truck. They take it through processing. Does it separate? And just because I've never done an oil change
Mhm.
out, so can they actually see the amount based on a centrip? I'm assuming probably a centrifuge or something could be used to spin the water out or something, or
Oh yeah,
what's the indicator there
well,
other than the?
there's a number of different methods. I mean, they'll take and use a freezing temperature and then vacuum the ice away, like Folgers freeze-dried coffee many years ago. I don't know if you remember those ads, but that's one of the ways. They'll take and spray the windings down with hot oil to try and draw the moisture out of those little pockets that I told you that was hiding in.
Mhm.
So there's a number of different ways, and this has been done for many, many years. We have another solution that we call the Trojan dryout system that actually will filter the water out of the oil quite effectively, but it does it while the transformer is still in service.
Really?
Now, here's what that means. Remember, we talked about equilibrium, how when you're at operating temperature, you have a balanced water and insulation,
Mhm.
water and oil. Well, if you're filtering the oil while it's in service and at operating temperature, as you draw the water out of the oil, you're pulling it out of the insulation.
Gotcha.
So
Gotcha. So
now,
I can see the benefit to that then.
and why is this important? Well, there's a lot of customers that don't want to take the transformer offline for 9 days or 10 days or whatever it's going to take. And this
P&L
can be done
impacts,
online.
because
Yeah.
ultimately it still comes down to whether or not whatever the viable the product is making
Yep.
money, and if you're not, it's
Sure.
the electrons,
Yeah.
and so
But
there's always that aspect as
but
well.
getting back to DFR, to dielectric frequency response, basically what it's doing is doing this extended power factor measurement in a large range, taking the response that it gets and the geometry of the response, and using the laboratory modeling to assign a percentage. Now it is temperature sensitive, so it's important to get a good temperature reading when you perform this test. But it's one test. It's done at 200 volts. I mean, it's a low voltage test, but very sensitive and easy to do. I mean, you just tie all your primary and secondary bushings together, create a short circuit and let it do its thing.
So from a cost perspective, DFR vice DGA, and I know you can use them in combination, of course, as well, or whatever the
Mhm.
customer desires.
I would recommend, yeah, for
Both
sure.
of them. So you
Yeah.
would recommend both the DGA and
Yeah,
the
and
DFR?
it depends. Again, as I said before, if your low frequency power factor measurements are, down in the lower end of the curve, and your PPM is from your DGA saying, yeah, you're fine, you save yourself the trouble of having to do DFR. It's
Okay, that was going to be my
when
next
you
question.
have
So
that.
it's not a must do DFR in
Correct.
combination. It's
Yep.
only if you have the indications of moisture, basically.
Very much
Okay,
so.
gotcha.
You betcha. So now I want to go a little step further, and we've talked about where the moisture comes from in the transformer, how we detect it and how we determine what the content is, and then look at various drying methods. There is one more that is in the industry today, and it's fairly new. They do this low frequency voltage injection to try and heat the windings. You have to pull the oil up, but then they heat up the windings, and it's supposed to help dry all the moisture in the insulation. But you have to you have to rent the diesel generator to power it up first of all,
Gotcha.
and then you
Gotcha.
have a big inverter box, and then the other thing that, and I don't really have enough historical information on this, but without oil cooling, I mean, you're trying to keep the windings cooled down. It's one of the
Right.
reasons you have the oil. If you're heating the windings up, how much potential damage may be happening, to the insulation just because of that heating process? I don't know. Again, I don't have data. I know that it
Right.
takes about 9 days or so to complete the process while the transformer's offline, and then you're putting the oil back into the transformer, and hopefully you process the water out of that oil before you
Hopefully.
put all that water back in. But it depends on the type of transformer, the location of the transformer, how much moisture you have to pull out. Can I take it offline? Do I not want to take it offline? So there are a number of options available for mitigation. Now,
Gotcha.
one of the things that we know in terms of common failure points on a transformer, number one is the onload tap changer. That's a pretty significant failure point because it's the only moving part in the
Right.
transformer, and it creates a high amount of arcing in energy every time it moves from one tap to the next. So that's one that has to be thoroughly tested, and I think there's new methods coming out from IEEE to assess the health of your onload tap changer, and I hope everybody gets a chance to see that, because that's a topic for another day. But the other failure point that everybody gets concerned with, of course, are bushings. Now, generally a transformer, if it gets treated properly, can last 50, 60, even longer
Right.
years. Bushings, they're not going to last that long. 20 years, maybe 25 years max on a bushing. So at some point in time, you're going to have to replace that bushing, or all the bushings some point during life, right? The big
Right.
question is, do I do it soon enough before I have a catastrophic failure? And I call bushing failure the Roman candle effect, because that's exactly what it looks like. And it is one of the major causes of catastrophic failure of a transformer. When I say catastrophic failure, I'm talking about, you know,
Jacob's laddering and all that
yeah,
other fun jazz.
complete meltdown. And I've got
Right.
videos that would make your hair curl in terms of bushing
Ooh.
failures and what they can do. So, basically what we do when we go out and we test the transformer, we're looking at the bushing. If it's an oil-filled bushing, you're looking at the sight glass to make sure the level is correct. You don't want any charring or any, it should be nice and clear, um, without any discoloration. We examine the porcelain to make sure there's no cracks. We're looking at the gaskets. We're just kind of doing a visual inspection. Now, some may do, while the transformer's in line, do an infrared, take one of our infrared cameras and look for excessive heat and compare it to the other bushings, because heat
Mhm.
is always a sign that you've got some kind of current leakage, and that
Right.
generates heat. So that's a good way. But basically what people do is they'll power factor test the bushing. They'll look at the power factor. They'll do what they call the C1 test and compare that to the nameplate, and it should be within a certain percentage that's stamped
Right.
on the nameplate. Then they might even do a C2 test, and I always recommend a C2 test. And I know there's not necessarily anything you can relate to in terms of the nameplate data. It's more of something you have to keep historical analysis on and looking for that rise. But a C2 test looks at a different part of the bushing in terms of the health of the insulation. So C1 and
Gotcha.
C2 test, power factor. You also want to do a tip-up test where you do power factor at various voltage levels to make sure that it's stable, regardless of the
Mhm.
amount of voltage you're putting in. But one of the things that causes bushing failure, or early bushing failure, more than anything else, can you guess?
Early bushing, I would say, I don't know, excessive voltage is being applied or something along those
One
lines.
of them, moisture.
Moisture. Well, yeah.
Gotcha. Okay, where
Got
you
me.
been the last half
On
hour?
the topic. I know, geez, I'm slacking. Well,
So
and that does make sense. Now, what is that material? So I know we mentioned the porcelain, but the actual like the gaskets and things like that, are those rubberized? Are they a different material
oh
or
yeah, it's a rubberized
okay?
polyethylene seal. Yeah, it's good. But one of the things that is definitely overlooked is you can do, and IEEE now has added this to their recommended guide for field testing transformers, doing a dynamic or dielectric frequency response on the bushing itself to get
I'll
a
be dang.
good
Okay.
indication of the amount of moisture.
Wow.
Because the moisture gets into it's kind of like what it does to the transformer, but it's infiltrated in different ways and in different parts of the insulation and the bushing. So,
Gotcha.
dielectric frequency response, the epoxy bushings that are solid and sealed are not going to be a problem, but RIP
Right.
bushings and oil impregnated paper has a very strong tendency to fail because of excess moisture. And again,
Got
you're not going to necessarily see this in your C1, C2 test because remember, it's allowed to get a little bit worse year after year, and you expect that
Right.
because it's starting
Right.
to break down a little bit, but it's still within acceptable range. Well, you're doing the test at 60 hertz. All right. Now,
Gotcha.
just like a transformer, if your initial C1 test, you bring this down from the 1 or the 10 hertz range and see that elevated, then you can take your DFR and get a good indication of how much water is in that bushing. And that is one of the things that can help to determine when am I going to replace this bushing? Because you can have a wet bushing and you could have a acceptable C1, C2 test and not know
Gotcha.
that at some point in time that thing may fail prematurely.
It's just it can be more of an isolated instance that's not necessarily going to be caught in the overarching power factor study of it if you're not studying the bushing
Absolutely.
specifically.
Yep.
Gotcha.
Yep.
Now
Yeah.
we've
And
kind of go ahead. Sorry.
there's been some really good engineers that have studied this through IEEE on the Transformers Committee, and we just wrote again in this new field, this new guide to recommended practices for field testing. It does cover new techniques for on-load tap changers. It does cover techniques for doing dielectric frequency response on bushing. So it's adding all this. We don't want our transformer to fail because of the bushing, because bushings we can replace.
Fairly easily
Now,
comparatively speaking,
yeah, now you don't want to have to just replace it because, well, it's 20 years old. Well, that, age might be a determination for when you replace your bushings. But if, 12 years, into its age, it starts to create a moisture issue and your C1, C2 readings are okay, nobody's going to tell you, hey, don't, why are you going to replace that
right.
perfectly good bushing? So that's when we run into trouble.
No, completely understand. And then I'm trying to wrap my head around it. So I understand that moisture is an issue. What actually happens in the insulating material? Like, is there a treeing concern
Yeah.
or what
Yeah.
is the overarching impact on a powered transformer?
Again, it starts with little voids in the insulation, little
Gotcha.
holes. And then you start to get the partial discharge and then the treeing effect in the insulation. Okay. Then the next thing you know, you've created a hot spot and you're probably going to start getting all kinds of gassing going on and it's going to fail.
Gotcha.
And it's all because you had these little pockets of moisture that just started to bubble, trying to escape and punch through that
Makes sense.
insulating material.
And that so would you say that's pretty much the root cause there is the constant degradation? You introduce the moisture, it causes
Yep.
micro treeing,
Oh yeah.
breakdown of the insulation, and that
Yep.
is ultimately what causes the
And then
catastrophic
it's
failure.
gonna be too late.
Right, right. Very, very interesting stuff. And then, so just in general, what are some other concerns or some of the new tech that you see kind of coming out?
Mm-hmm.
Obviously, the industry is always evolving and things. We already mentioned the various testing from DGA and everything else that's
Mm-hmm.
out there. Are you seeing any other new stuff on the horizon?
Yeah, actually, some of the manufacturers of equipment have come up with, and this has been out for a while, but it's very little known. And I'm actually hoping to do a presentation at Power Test on this one next year. And that is, I've always talked about leakage reactants and SFRA in terms of looking for mechanical failures. And I did a whole big thing on through faults as well. And a through fault is a fault that happens on a transformer that's outside the protective zone of the transformer itself. So if you have a fault on a transmission line, current's going to be flowing through that transformer, and that can cause mechanical deformations in the windings of the transformers. And this can actually go undetected because people don't always have through fault monitors on there. 100% of the time it's included in your microprocessor relay. It's just that people don't think to enable it and keep record of these through faults that have happened, because not one through fault could be catastrophic. You could have a series of them that eventually create some structural problems in the windings of the transformer itself. So, SFRA has been around for a long time. So has leakage reactants. Also known as short circuit impedance test, where you're comparing the impedance of the transformer to what's stamped on the main plate, and it should be plus or minus
Right.
3%. And so there's various ways to look at mechanical failure as well. But here's one that people probably don't know very much of, and I know of at least 3 vendors that provide this feature. When you're doing a leakage reactance test, they have a little checkbox on there called, do you want to do frequency response to stray losses? Or FRSL, which again is a tongue twister, and I'll bet you that people that see that box don't really know what that is. Well, what it is, it's not looking for a mechanical failure at all. In fact, I believe it was Hydro-Quebec many years ago looked at various means of looking for mechanical failures to go along with SFRA. And what they started to do was, start to ramp the frequency up of the test signal to see if there was any indication. Well, it really wasn't providing them anything until they finally discovered years later that, hey, if we do this test and we measure only the resistive component of the impedance, as that frequency increases, okay, it's going to drive your resistance up because you're pronouncing the skin effect of your conductor. In other words, current travels through a conductor. If you take a cross section at DC through the whole circumference of the conductor, as you increase the frequency, it's only traveling over a portion of that. Well, the farther up you drive your frequency and measure the resistance, the higher the resistance is going to get. So what they discovered is, if we take this measurement, do a short circuit impedance test, just like you're doing leakage reactants, and we measure the resistive component, we drive it up to 400 hertz, all 3 phases should be within each other. Well, if they're not, let's say one phase is higher than the other, that's an indication of what we call a shorted conductor bundle, which means that the
Interesting.
windings of the transformer, it's not just one piece of solid copper that we wind around, it's a
Right.
bundle where you have little conductors with insulation in between. Well, if any of the insulation in between has caused a short circuit within the bundle itself, that will drive the impedance up on this measurement.
Gotcha.
So we call that a shorted conductor bundle, and that could be a manufacturer's defect that hasn't reared its ugly head until years later, when you start to develop again a hot spot and
Hmm.
partial discharge and insulation breakdown, and then you say, well, I guess we just had an insulation failure.
Right. Right.
so this is a very interesting part of advanced diagnostics that people are starting to hopefully learn about and understand why we do it. Like Robert
Ab-
Stevenson said, um, you know, if you don't know why you're doing it, don't do it.
Fair enough. Yeah. Yeah. Yeah.
So it's important to understand, when we're technicians in the field and we're out testing transformers with various different methods, to know why we're doing it and what we're looking for and what do those results really mean. Because in
Absolutely.
the end, it's all about making sure the customer gets the most advantageous situation to spare his transformer for additional years.
Absolutely. Now, you brought up some pretty interesting points. You mentioned the relays inside of the stations and things like that. Are
Mhm.
there any real-time monitoring tools that kind of monitor the health as things go on? And is that data aggregated typically?
Yeah, transformer monitoring is starting to get more and more popular. And driving down the cost, it used to be really, really expensive, not only to install these, but also have the means to communicate. Well, with the digital substations now, continuous monitoring is can be very effective in determining a number of things. I think what and in fact, I was on a working group to update the recommended practice for transformer monitoring that we just went to a final approval for the next fall meeting. And there are certainly some great benefits to keep a constant eye on the gassing of the transformer, the temperature of the transformer. They have now sensors that can measure relative humidity, so you're actually monitoring the moisture content. And you know, I would never, as a field technician, want to rely on the information solely from the
Right.
monitor. But if you start to see elevated conditions, whether it's gassing or whether it's moisture, then it's time to take a closer look. So it can give you more relevant or more relevant background in terms of when to go test your transformer than just saying, well, we do it every year.
Right, right.
So
Well, and it seems like you could almost have like a real-time maintenance program based on what you're seeing degradations on, with inline or
mhm,
or on the system and just trying
yeah.
because just based on the conversations we've had, it seems like trend analysis and the
hmm
swapping of vendors constantly, some folks are going to go with the lowest bid on something or something along those lines.
Yeah. Yeah.
It seems like the aggregation of the data and then
hmm
parsing that out and making it readily available to whoever's doing the servicing or
Oh, right.
or
Yeah.
gas or moisture abatement.
hmm
It seems like that to me, from again the layman's perspective, just kind of makes sense. Like,
Right.
everything is data centric to me
hmm
in my
Sure.
mind, anyway.
Well, what's interesting about this in the industry is that probably the utilities that have their own engineering department and test technician crews, um, they have a better opportunity to have information drilled down to the technician in terms of what they do and why they do it. Um,
Right.
when you when you are a utility, maybe a small utility or an industrial or company that farms out the testing, okay, you do that for a reason because you don't have anybody to test it or you don't want to hire people to
Right.
test it. Okay, but
Right.
what we're missing here, Micah, is that relationship with the person that is going to test and the
Absolutely.
guy that's writing the specification on what test to run. Because if I'm not good enough to have my own test crew, am I really writing the right specification? And what am I writing the specification around? Um,
Right.
there's got to be a connection between what the experts, people at IEEE, are developing
Absolutely.
and doing to drill down the people that are making these decisions.
Right.
And that's again, that's why education's so important and a consistent thing.
Education, and then of course just data availability, right? If you
hmm
don't have that aspect of it, then you're kind of shooting in the dark, or at least that's what it seems like it would be to me in some instances. And like you said, if you're on an annual preventative maintenance program where that's when you're
hmm
doing your DGA and all the various tests for that, then
Yeah.
you don't really, you're not drawing necessarily. And like I said, I don't work in the industry enough to where I mean,
hmm
I'm sure there are some companies that are doing it right, but just making sure it's not just addressing the maintenance for the sake of doing the maintenance. You're actually
Absolutely.
evaluating the trends. Is
Yeah.
that something that you see to kind of be an obstacle to be
Oh yeah.
overcome?
Well, I'll tell you, with the onset of artificial intelligence and the
Yes.
the availability of good data and being able to have the machines learn, and I would imagine that at some point in time, just like protective relays. I mean, when we were in the electromechanical age, you had to go out there once a year and check the calibration. Well, when they
Right.
went to the digital age, there were so many conflicting stories about how long you have to should wait between full testing. It was all over the place. I remember being in a workshop going, how often we got to test these things now? Do we still go out? There's nothing to calibrate, right? Well,
Right.
so there was many 3-hour arguments and Jerry Springer fistfights over that topic. But finally, NETA came out with good recommendations on interval testing.
No, absolutely. And it's amazing because I mean, we've had electricity since Edison and Insull and everyone else, and to
Mm-hmm.
see that we're seeing the amount of technological innovation still
Oh,
going on, even all these decades and centuries later now, if you think about it,
yeah,
is just truly phenomenal.
it
It,
is.
it
Yep.
really is wild to see. And to know that, I'm a big fan of the SEL guys, and that's not a
Mm-hmm.
shot against Siemens or ABB or anybody else, but just to see the innovative products that are still coming out to better the grid, and
Oh, yeah, yeah.
just it's insane to me.
It's
So
it's
is
amazing,
that kind of what your take is as well?
yeah, and one of the good. I mean, if we switch from the Transformers Committee to say the Protective Relay and Controls Committee, um, these standards or these techniques, these things like traveling wave or you know different types of protection technology, it's a conglomeration of all those vendors that you're talking about, having these top level engineers that get together, not in competitive spirit, but more of a
Right.
collaborative initiative to get things done. I mean, you'll see behind me our Intolerant booth. Right behind me is our friends from
Prolite.
from Waukesha, Prolet.
Yeah.
Okay, 2 doors down is our friends from Virginia Transformer, all very good rental customers of ours, which is wonderful to have surrounding you. But um,
Absolutely.
the engineers that develop, design, build, work with, study are all part of that Transformers committee, and they're all, they don't care about the commercialism of being part of that crew. They're concerned with, how do we make, the power systems more stable, more reliable.
Absolutely.
Um, so that's what I like. And being an Intolerant, we're a friend to all because we
Right.
rent every vendor, every vendor's piece of
Absolutely.
equipment there is available, so the user has his choice. But I'll tell you, in terms of selection, um, what should I use? Well, what are you testing? How are you testing? What are you familiar with? It's never a clean cut answer.
No, couldn't agree more on the collaboration aspects. So if you look at it, and this is just, and I'm sure it exists across multiple industries, but to
Mm-hmm.
me, just walking in from the military mindset, knowing that we have that very collaborative / friendly competition with other ships and things
Yeah,
like that, but just to be exposed to it through the various conferences and to see how
yeah.
awesome it is for everyone to be sharing. And it doesn't matter if it's direct competitor A talking to direct competitor B. They're
Mm-hmm.
still, sharing stories, collaborating, working through problems together. And
Mm-hmm.
I have yet to run across a guest that's not willing to share their knowledge with
Oh,
the
absolutely.
collective,
Yep.
So
Yep.
I find it just to be a phenomenal industry for that. And like I said,
It
perhaps
is.
it's in other industries and I'm just ignorant to it. But to me, I just feel very, very good and fortunate to be exposed to it.
Yeah. Well, it's kind of like the Army Navy game, right? You guys
Absolutely.
were battling it out, but served your country with equal importance.
Absolutely, absolutely. Well, what are some of the other just any general thoughts on Transformers collectively? Like I said, whenever I reached out to Greg and said, "Hey,
Mhm.
who's my Transformer guy?" He's like, "Drew," without hesitation.
Well, I'll
What
give
are
you
some of the other things that would
I'll
be
give you
important?
one more important topic, Micah, and that is what to do about going from mineral oil to natural esters such as FR3. Um,
Okay.
and I get a lot of panicked calls now and then from people that have switched, and their power factor measurement goes, where it used to be around 0.32, now it's at 1. And anytime you see an
Really?
elevation in power factor measurement that drastic, you're going to hit the panic button.
Right.
But what I can tell
Absolutely.
you is the natural insulation characteristics of these natural esters, that is not untypical. And
Okay.
it's certainly no cause for alarm. I mean, if you're going to switch to a natural ester, FR3, or any of the others that are out there, this is good. This is like running the top level synthetics in your transformer. It does a better job
Okay.
cooling. It does a
Gotcha.
better job
Yeah.
insulating. But your typical dielectric measurements might be a little off.
Get a little
Don't
wonky.
panic.
Now,
The
with that being said, now does whenever they do the swap over to the natural esters, and this is the first
Mhm.
I've heard of natural esters, so I definitely want to kind
Oh
of
yeah,
dig into
yep,
the composition of it. Does
yeah,
that
good,
usually
good.
come with a change to the nameplate or anything like that, so
Oh,
they can
oh,
kind
oh,
of
oh,
expect
oh,
that?
yeah, yeah. It
Okay,
will. I mean, and that's important. I think when you switch over, you have to get it all but at least 7% of the original oil out before you fill it
gotcha.
with FR3. There's some guidelines for that. The other thing you're going to see, where if you were in the 30 to 40 range in ppm in your DGA with mineral oil, and you were starting to think that you've got some
An issue
mitigation
of
to
some
do.
sort, right?
FR3 and natural esters tend to are very, very dry oils. Okay, they'll suck
Okay,
moisture in from anything. Your ppm may go
okay,
up to
gotcha,
300. And you know what?
gotcha.
No cause for concern. The saturation point of FR3 is 100 times that of mineral oil.
Really?
So I just be aware of that, because I've had people I had a guy at a transformer in a mine shaft, and they were running FR3, and his ppm was over 200, and he was freaking out thinking, I gotta get
I
this
would
thing dried out.
imagine.
No, 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 don't,
It's
don't.
actually just doing its job. It sounds like it will
Mhm.
actually like wick more water away from the vital
Oh
part
yeah,
that is
oh
the
yeah, yeah.
insulation.
It does a
Okay.
better job in insulating the windings of the transformer. Much better job. And
I
you know,
would
I'm
imagine.
not a
Okay.
I'm if there's any person out there that is dealing with a natural ester and is looking at funny readings, because I mean your TTR or winding resistance may go down, your power factor is going to go up, your
Right.
moisture readings are going to go up. Consult with the manufacturer of the oil, because these guys
Okay.
are all chemists, and they will give you perfect instruction, whether that's Cargill or somebody else.
Right.
Just make sure that when you change out, you know what to expect when it comes to testing down the road.
Gotcha. Now, how prevalent have those natural esters become? Are we seeing them more widespread throughout the industry? Are we on the
It's
cusp? Would
starting,
you
yeah,
recommend it get swapped?
it's starting to. Well, what I recommend, I couldn't say. It's
Fair
totally
enough.
up to
Fair
the
enough.
research of the customer, but
Gotcha.
I would say that, yeah, it's starting to gain some traction. I think there is a cost. Some
I
might
was
be
about to
cost
ask.
prohibitive. I'm not sure, but I do know this, that we've had test standards for transformers filled with mineral oil for a heck of a long time. We don't really have
That was going to be
solid
my next question. Yep.
recommended standards for
For
these natural
natural
esters,
esters.
but it's coming. We're working on it. But Cargill has some good publications on theirs, and I'm sure the others do too, in terms of what it brings to the table and what you should expect.
If you could assign a percentage, kind of like what you're seeing out there, just as a broad, coverage, about what percentage would you say are using the natural esters
I
nowadays?
think now we're probably up to the 15-20%. Maybe, I don't quote
Okay,
me on
so it's
that,
it's
but
definitely starting to make
it's starting
inroads.
to, yeah, it's starting to get
Okay,
more popular, no question about it. It has for some time. It's just mineral oil was just always the go-to. Was cost effective, and if you took care of it, it took care of you.
right. No, it totally makes sense. But it does seem like the natural esters are definitely more viable as far as the durability and and the lengthening of life of the materials, which I'm sure the
Yeah,
customer considers
seems
when
to
they're
be. Yeah, I mean,
evaluating.
they
So
one of the chemists was telling me that they expect they could run the transformer at 120% of their rated load, and that's pretty significant. And
wow. No,
I mean,
that's
I wouldn't
wow.
start doing that. Not that I don't
right.
trust what he's telling me, but I do have my cautious limitations.
right, right,
Yeah.
right. No, that is some very enlightening stuff, and that's when I'd never heard of the natural esters again. I wouldn't
Mhm.
expect that I would. I try to study, the NFPA, the IEEE standards, and then just various other aspects, and that's a new one on
Mhm.
me. And
Yeah.
hopefully that'll at least enlighten some of the transformer techs that are out there that may not have been exposed to it yet. Now,
Sure.
do you see it happening more regionally, like down where the humidity is more of a concern, say down in the South, vice the
No, I think it's
Midwest, or is it
yeah. No, I think it's been pretty even throughout. I mean,
okay?
environmental factors really don't have a whole lot to do with your insulating fluids, because they are sealed.
Gotcha.
Caustic environments will wreak more havoc with your bushings. and cause corrosion in places you don't want
Right.
corrosion and things as such. But aside from that, no, I think there is some viscosity issues at really, really low temperatures. Again, that's something you have to check with the manufacturer on. So it might be that,
Right.
depending on, if you're up in Alaska, and might be different from if you're down in Florida.
Right. No, it totally makes sense. And this has been just an absolutely phenomenal, just a phenomenal conversation with regards to transformers. Again,
Mhm.
you're the first that we've kind of delved into this, and I'm trying to get a little bit more into relays, a little bit more into the
Sure.
distribution side, and what's out there
Yep.
for transmission lines, and
Hmm.
trying to get some more macro perspective stuff going on. So, greatly appreciate you sharing your experiences, and consider
Thank you,
this an
Mike.
open invitation if you ever want to
You
use the
bet.
platform to spread the knowledge of what the latest and greatest
Hmm.
happenings are. And it
Yep.
just seems like there is like a educational bridge to get bridge to gap there, I guess would be a way to
Yep.
look at it. And again, I don't blame the technicians or the companies. It's just a matter
Sure.
of, do you have somebody or somebody dedicated to kind of
Yep.
staying in touch with the latest
Hmm.
happenings?
Yep.
Obviously conferences are good for that, but
Hmm.
spreading the knowledge via as many channels as we can seems like
Oh
it's
yeah.
the best way to go
Well,
about
I
business.
would
So
say to your viewers out there, my phone lines and email are always open. If you want to learn more about it, let me know. If you'd like to try it at your utility, let me know. If you'd like to have a little training on how to do DFR, or frequency response to stray losses, or any of these approaches that we're talking about, just let me know, because there's nothing I love better than to go out in the field and train and share knowledge with, those that it matters to.
and that's really what we have to continue down the road of if we don't want to lose all this amazing knowledge that's been ingrained through the
Yeah,
generations. So
absolutely. Absolutely.
truly awesome, Drew. And again, I know you're a champion for the industry, as it shows through all your work with IEEE and sitting on the relay working group, and of course the transformer committee as well. And so truly just dedicated to the advancement of the collective knowledge, and making sure everybody has a grasp of the technology that is out there. So
Yep.
you are a man on a mission, sir, and I greatly appreciate it. There is no
Well,
doubt
thank
about
you.
it. And even if we impact just a couple of folks as this thing grows, I think it'll be
Always worth it.
worthwhile in spreading the knowledge.
Yeah.
And if you don't mind, are
Mhm.
you open to connecting with? I know you work at IntelliRent.
Mhm.
Can you kind of give us your email address if you don't mind sharing a good way for folks to reach
Oh,
out to you? Do you prefer LinkedIn
absolutely. And if
or?
you want to put on my title page on the from the presentation, you're more than welcome to. But
All
it
right, I
is
sure will.
D Welton, DWELTON at IntelliRentCO.com.
Awesome. We'll share that. And then, of
Yep.
course, do you spend much time on LinkedIn? Some do, some don't. So
Oh, absolutely. I'm there at least every other day when I can. You betcha. Yeah.
you're doing better than me. I'm on there. It seems like every dang hour of the day these
Yep.
days. So
Well,
it can be a little bit of an addictive
you're doing a
thing.
great job, Micah. These interviews are great. I've watched a number of them, and I was
Bless you.
very
Thank
excited to
you.
come join you. So keep up the good
And
work, my friend.
absolutely, and you were definitely, like I said, anytime any new standard, anything comes on that you just want to get out there. Like I said, we don't have this vast audience. I think we're maybe getting anywhere between 10 to 13,000
Hmm.
impressions a week, which I mean to me isn't horrible. But we're not
Hmm.
Mr. Beasting over here. But if we can just save somebody some pain at some point, I think it makes it all
Oh
worthwhile.
yeah, absolutely. By all means.
Awesome, Drew. And again, thank you so much for joining us. I hope the
Hmm.
rest of the TND conference out there goes phenomenal. Just talking
Thank
with
you.
you before the interview has definitely given me definitely some thought consideration. We'll be at a power
Sure.
test, of course, next year in Orlando. I'd like to catch up with you there, of course, in
Sure.
person.
You bet.
And
Yep.
then we're gonna rock and roll and try to make TND and a couple of the other ones come about and get out there and
Awesome.
hop on the circuit, as we can remove
Great.
more of the responsibilities that all the hats we have to wear as a solopreneur over here. So
You bet.
hoping to buy some
Absolutely.
bandwidth back to go out and network a little bit more. But again, I truly appreciate it. Hope the rest of your conference is phenomenal, and happy to have you on at any given time. So consider this an open invitation.
Awesome. Well, thank you so much, Micah, and best of luck in your journey forward.
Thank you very much, Drew, and likewise.